You have probably heard about machine learning, but you are not exactly sure how to use it in the context of GIS. You want to get to know about machine learning algorithms that are used in GIS and remote sensing? Then this course is for you. The field of artificial intelligence has progressed rapidly in recent years, matching or in some cases even overperforming human accuracy at tasks such as image recognition, reading comprehension, and translating text. The intersection of artificial intelligence and GIS is creating massive opportunities that weren't possible before. Artificial intelligence, machine learning, and deep learning are helping us make the world better by helping, for example, to increase crop yield through precision agriculture, fight crime by developing predictive policy models, and predict when the next big storm or virus outbreak will hit and being better equipped to handle it. A bit about myself. I'm a remote sensing and GIS expert with 10 years plus experience in these topics. I also teach and train people on remote sensing and GIS and give regularly courses at different parts of the world. And today I am delighted to introduce you to this interesting topic. GIS and remote sensing are an important part of our daily life, though many people do not realize this. From learning to code, to building web maps, or doing data collection in the field, if you want to learn GIS, it's never too late. And don't forget, the main aim of this course is to introduce you to the concept of machine learning and how to apply it for GIS and spatial analysis. During this course, we will learn the following topics. What is Geographic Information Systems, or GIS, and where we use it? What is remote sensing and where we use it? What is the main principle of GIS and geodata types? Where do we apply GIS? Where do we apply remote sensing? I will provide you with a few examples. Then we will cover topics related to machine learning and artificial intelligence in GIS and remote sensing. After a very short general introduction to machine learning, we will talk in more details about types of machine learning applications in GIS and their applied examples. I will equip you with a list of GIS and remote sensing software packages that you can use to get started with using machine learning for GIS analysis. Finally, I will provide you with two hands-on examples of application of machine learning in GIS. Namely, we learn how to do segmentation in QGIS and how to classify satellite images both in QGIS and Google Earth Engine, and I will also provide resources needed to complete this assignment. So, let's get started. Hi there, and welcome back to this course on Machine Learning in Geographic Information Systems, or GIS. The topic of today's lecture is on basic of GIS. Today we are going to talk about applications of GIS. We will learn what is GIS and how to define it. Finally, I will tell you about geodata and its two main data types, raster and vector data. This is important for you to understand when we are going to talk about machine learning algorithms later in this course. This is because data is very important for such algorithms and serves as a main input for them. Every day, millions of decisions are being powered by GIS. From pinpointing new store locations, to predicting climate change, to reporting power outages, to analyzing crime patterns and epidemics patterns. You might be wondering, but why use GIS? Because geographic problems require special thinking. In GIS, you connect data with geography and you understand what belongs where, because you don't fully understand your data until you see how it relates to other things in a geographic context. There are numerous GIS applications. Let me give you some examples. GIS is often used to support decisions in agriculture. It is used to empower decisions in business and for internet applications. GIS is used for crime applications, to track epidemics, insurance GIS applications, humanitarian applications of GIS. It could be used for environmental and energy applications, for real estate, transportation, utilities, volunteer GIS and open technology, and many others. So, what is the definition of GIS? A Geographic Information System, or GIS, is a framework designed to capture, store, manipulate, analyze, manage, and present spatial or geographic data. GIS applications are tools that allow users to create interactive queries, user-created searches, analyze spatial information, edit data in maps, and present the results of all these operations. Rooted in the science of geography, GIS integrates many types of data. It analyzes spatial location and organizes layers of information into visualization using maps and 3D scenes. With this unique capability, GIS reveals deeper insights into data, such as patterns, relationships, and situations, helping users make smarter decisions. And now let's move to the geodata. What is geodata? Geodata is location information stored in GIS. By viewing data with a geographic component, we see it through different lenses. Geodata tackles the problem about location because geographic problems require spatial thinking. Let's dive into the types of geodata. As it turns out, there is not one single type of geodata. Instead, geodata exists in various forms. For example, we commonly use vector and raster data to depict geodata. Vector data consist of vertices and paths. The representations of different types of vector data could be seen on this slide. The three basic types of vector data are points, lines, and polygons. Each point, line, and polygon has a special reference frame, such as latitude and longitude, which is simple geographic coordinates. So, first, vector points are simply xy coordinates of that location. Secondly, vector lines connect each point or vertex with path in a particular order. Finally, polygons join a set of vertices, but it encloses the first and last vertices, creating a polygon area. Raster data is made up of pixels or grid cells, as you can see on this slide. Commonly, they are square and regularly spaced, but rasters can be rectangular as well. Rasters associate values to each pixel. Continuous rasters have values that gradually change, such as elevation or temperature, but discrete rasters set each pixel to a specific class. For example, we represent land cover classes to set of values. Now, as you are familiar with the main definitions in the field of GIS, let me move and tell you a little bit more about remote sensing. So the next set of lectures are going to be about basics of remote sensing. This is, along with the basics of GIS, is very important because in our particular course we are interested in applications of machine learning in both geospatial context in GIS and remote sensing. Afterwards, we will move to machine learning itself. So stay with me and see you in the next lecture.